Okay, so this one I'm going to show you about how to name acids. But before I can show you how to name acids, I have to show you all the different things that can happen with polyatomic ions in terms of changes in oxygens and how we have to name those differently. So let's go with Nick the camel ate a clam. So this is one where you've got lots of different oxygen possibilities. So clam is chlorine. All right, it's got three consonants, C, L, and M. So that's three oxygens. Okay, so what's the charge on it? Just one vowel, so it has a -1 charge. So we call that chlorate. Now, there are polyatomic ions that exist that have more or less oxygens than this. So what do? We have to have a different way of naming these. So what if it's ClO4? If you have more or less oxygens, it doesn't tend to change the charge. So the charge stays the same, the oxygens will be different, which will change the behavior, so it does matter. All right, so what do? We put the prefix per in front of there. Perchlorate. There you go. Next one. What if you have less oxygen? Well, if you have one less, these we'll deal with quite a bit because a lot of stuff out there are the things that end in ite rather than ate. So what we do is we can't call it chlorate. We change the ending to ite instead. This is what we call the chlorite ion. A lot of nitrites, sulfites, things like that. Those are things that are produced in industry and cause things like acid rains. A lot of sulfites are things that give people a hard time in terms of if they're in food. Okay, so not everybody, but some people. All right, what's the last one right here? Well, this one actually exists as well. Ouch, what do? Well, we keep the ite and we put a hypo in front of it. So that becomes the hypochlorite ion. The hypochlorite ion is actually the major component that makes bleach as effective as it is. It's very unstable and just kind of does lysis on cell membranes. That means it rips the cell membrane apart. And, well, that's a good thing if you're trying to destroy that cell. If you don't want the cell to be destroyed, it's a bad thing. Okay, now, acids. What does it mean to be an acid? An acid is you have a negative ion that has hydrogens attached to it, and how well that hydrogen can split off that ion tells us a lot about the acid strength. That part of it is something we'll cover later, but for right now we need to know how to name these guys. Okay, well, the name of the acid, we're talking about hydrogens attached to oxyions, is going to be based on the name of the polyatomic ion. So let's go ahead and change some of this stuff right here. Now, hydrogens have a +1 charge. How many hydrogens you have to attach is based on what the charge is. All these have a -1 charge, so they're only going to need one hydrogen. Okay, so now I've created 4 different acids here. All 4 of these acids do exist, and I've got to be able to name them. The ate thing that you use is the most, so if you've got the ate ion, chlorate, phosphate, whatever, you attach the number of hydrogens and then you just change the ending to ick. Acids are icky. So that acid would be chloric acid. This one right here, HClO4, is a different acid. What do you do? Well, again, you just use the polyatomic ion, so we'll call that perchloric acid. Well, what if you got one less? This is where it gets a little weird. So we can't call it chloric acid. We change the ending to -ous. Why? It's got some kind of Latin origin that I don't really understand. So that becomes chlorous acid. What if we're attaching it to this one right here? We still have to have another name, but again, it's based on the polyatomic ion, so we'll call it hypochlorous acid. So that's what we do when we're naming stuff in terms of acids that are made by attaching hydrogens to the polyatomic ion. Okay, so what if, though, here's the thing, we have other ions too, right? So what if I have something like chlorine? Well, chlorine's a negative ion. Could we have hydrogen attached to it? Sure, I could have a hydrogen there. Hydrogen has a +1 charge. I just made an acid. Now, I can't call this chloric acid. Why? That's chloric acid. So if you've got hydrogen attached to just a nonmetal, what we do is we put the term hydro in front of there. So we'd say hydrochloric acid. I know it seems kind of weird, but if you got hydrogen just attached to a nonmetal, then you put the term hydro on there. Let's take a look at another one. What if I have an oxygen ion? I think this will still show up. Let me move this. Well, oxygen has a -2 charge. What does that mean? Well, I'd have to have 2 hydrogens, so I get H2O. Well, technically, this is an acid. It's a really weak acid, but it's technically an acid. What do we have to say? We'd have to say hydroxodic acid, okay? Water. You could also call it dihydrogen oxide if you want to, or we usually just say water. If I want to have a little fun with somebody's going over to fill their water bottle from the sink in the back, I say, no, you can't use that sink. And they say, why? And it's like, well, because from that sink, it's hydroxodic acid. We wouldn't want that, would you? Well, it's just water. Okay, so that's just a dumb nerd teacher trick. Anyway, that's it on the acid naming thing. Now I'm going to try to put all that stuff together.